Let's discuss relational operators and logical operators. So the first one is to test for equality. If the left hand side is equal to the right hand side, then this evaluates to true, which is represented in C by 1. This is the negation of the previous one. So this is not equal to. A not equal to B evaluates to true if A equal to B evaluates to false. This is greater than, less than, greater than, equal to, less than, equal to. Same deal. So now let's have a look at the precedence. A equal to B evaluates to, let's just have a look at that. That's fine. A and B are 5. The result should be expected. Next we have plus A is equal to B evaluates to. Then we have A is equal to B plus evaluates to. And yeah, the other relational operators work in the same way. So first let's just see what's going on with the relational operators. Ignore that warning for now. So A was 5 and B was 5. A is equal to B evaluates to 1. And after that A and B are still 5. Plus A is equal to B evaluates to 0. So that is because that is the prefix operator. So A is incremented before the equality test occurs. So A is equal to 6, B is equal to 5. Then A is equal to B plus evaluates to 0 again, because that is a postfix operator. So because that is a postfix operator, first the equality is tested, then the increment occurs. So then after that A is equal to 6, B is equal to 6. Now we can come to the logical operators. This one over here is not. This is the logical and this is the logical or. So A plus A, logical and, A minus A. So I'm just going to say not and or, and imply for the rest of this video that those are the logical variants. So A plus A and A minus A evaluates to, let's have a look. A plus A and A minus A evaluates to 0. So what that means is we have A plus A, which gives us a non-zero quantity. However, A minus A gives us a quantity that is 0. A minus A is always 0. So something non-zero and something 0, that is equal to 0. True and false is false. So now the other logical operators, yeah, they work in a similar way. Now here is an interesting example. Not A plus B evaluates to something where B is something. So what is that? Not A plus B evaluates to 6 where B is 6. So what this means is that the not is evaluated first. Not A plus B. If it were not of A plus B, then it would have evaluated to 0. However, it is not of A. To that, we have added B. Not that we are taking A plus B and then taking the logical not. Now this last example here, not 0 or 1 and 0. So here's what's going to happen. First, just take a guess. You've probably seen it already, given the numerous times I've already showed that, but in case you haven't, just take a guess. See why, think why it might be giving the result it is giving. Ready? Not 0 or 1 and 0 evaluates to 1. So what happens here is, first the not is evaluated. So we have 1 or 1 and 0. Now here, next what gets evaluated is the AND. So 1 and 0, that thing evaluates to 0. Which means we are left with 1 or 0, which evaluates to 1. Hence 1. That's it when it comes to equality, inequality, and logical operators. Now we are ready to discuss conditional statements. So far we have been discussing programs in which there is no decision making as such. No element of choice exists. So let's change that. Right. So this is an if statement. So there are three parts to this. First is this if keyword. Then we have these parentheses, and inside them we have this Boolean operation here, this Boolean expression. So by Boolean I mean it is a combination of relational and logical. So basically anything which can evaluate to a definite true or false, that is a Boolean expression. So this here, n is greater than 100. This thing only gets printed if indeed n is greater than 100. So basically what happens is, the program first steps in over here. We evaluate this. If this is true, we execute this. Or rather, whatever is between these two over here gets executed if this evaluates to true. If this evaluates to false or 0, then we just skip over to this line over here. So let's just run that again. I gave it 100. Nothing, because that was explicitly a greater than, not a greater than or equal to. N is greater than 100. This gets printed anyway. This gets printed anyway. Sorry. Right. So now here we have a choice of whether to print this or not based on this. But what if we want to choose between two paths? If this, do this, otherwise do something else. That is provided to us through the else keyword. So what will happen here is, if this evaluates to true, this will be printed. However, if this evaluates to false, this will be printed, or rather this thing is what is executed if this evaluates to true, and this thing is what is executed if this evaluates to false. Let's see if it worked. It worked. So now if we wish to have a different thing, right now we are able to choose between two options. If we wish to choose between more than two options, we do have something which can help us. So that worked. So what we have here is else if and a condition. Else if and a condition and a block like that. So what happens here is, we step through like this, and we first evaluate this condition. If this condition is true, we print, and we ignore the rest of this and head straight down here. If this is false, we look at the next condition. If this is true, we print this and we head down. If this is also false, we check the next, and like that we continue. So what is important to note is that these conditions need not be mutually exclusive. For instance, if you observe here, n is greater than 1000. If this evaluates to true, then because of the way we have constructed it, this will also evaluate to true, and this will also evaluate to true. However, we only consider this one here. So the first one which evaluates to true, that one we consider, and then we just ignore the rest. If none of them evaluate to true, then we go to this else, and this else is also optional. We need not have this else. So when it comes to which ones are compulsory and which ones are optional, if you want to get into branching, if is compulsory here. You cannot have an else if or an else without having an if. The second thing is, you cannot put an else if after you put an else. So that's the only thing you really need to think of when it comes to if, else if, else if, else. And you can also nest them. By nest, what I mean is you can have an if statement, you can have an if else, and inside each of them you can have an if else again. So that program worked as I expected it to. So you can have an if else inside another if else combo, and there is no compulsion about the way you do it. I could very well have just deleted this. There's nothing at all. You can mix and match any way you like, apart from, of course, if you have branching, just put the if first. You cannot obviously have an else, and you definitely cannot have an else if without first having an if, right? So that's the way if else and nested if else works. However, for having a program that is simple and easy to understand, I don't really think it would be wise to have many levels of nesting. If you have many levels of nesting, gradually, if n modulo 2 is equal to 0, if n modulo 3 is equal to 0, or do some thing, and if n modulo 4 is equal to 0, do something else. So you can see that it's becoming complex, and if I keep going back and forth between this and having this again, it becomes a little complex. So try not to make it so very... In general, try to have your code simple and easy to understand. And a way towards that is a slightly flatter structure. I mean, there's nothing wrong with 2, but if you start going beyond that, it becomes a little difficult to read.